Last talk of the day is Detecting Malicious Files with YARA Rules as They Traverse the Network by David Bernal. Thank you.
Hi. Thank you very much. Thank you. Welcome to my talk. So, as he mentioned, this talk will be about how to detect malicious files with YARA rules as they are traversing the network. So, a little bit about myself. I'm a lead security researcher of SCILabs. I have around 10 years of experience in digital forensics and incident response. I have 9 DIAC certifications, and I'm a SANS mentor in Latin America. In addition to hunting for threats, I really like to hunt for free public pianos. That is one of my hobbies, and I really love it. So as you can see, that's me on a public piano in Paris. And I think that there should be more public pianos in Las Vegas. So back to hunting for threats. Why are you here? I want to help blue teamers detect malicious files using YARA rules and the Zeek framework. And the good thing about it is that they are open source projects. So I also created like a custom script, a custom Python script that will be also available to you so that you can enable this capability on your networks, on your enterprises. So what is YARA? Well, YARA is a tool created by Victor Manuel Alvarez from VirusTotal, and it can be used to identify malware families, malware samples, and create descriptions for these malware families. Now, the other component is Zeek, and we'll explain it later. Here's a small sample of YARA rule. So we have 3 parts. The first part is the metadata section in which we will add information about the description of the rule. What can it do? What can it identify? Also, we can add some other information such as the author and any licensing restrictions that we have. Then the second part is the string section in which we can have string patterns, also binary patterns and regular expressions based on the observations that we identify on the malware that we are analyzing. So then we have the condition section in which we specify the logical condition in which we are going to use those strings, those regular expressions or binary patterns, and we can additionally specify some other things such as file signatures. So now I'm going to show you a YARA rule that I created, that I developed, that is used to detect Microsoft Word documents that have strings related with automatic execution and that are very used in phishing attacks. So here you can see that I specified a license, and I added the description, the author name, and then we have 4 strings. So the very first 2 strings are related with automatic execution. They are functions within the VBA code in the Word document. And basically, the auto-open runs code whenever the document is opened and macros are enabled. And auto-close runs code whenever the document is closed and obviously the macro code is enabled. And then the last 2 strings are contained on documents that have macro code. So now let's go to the final section, and we can see that on the very beginning I have conditions to identify the file signature of those files, and on the second part I specify the condition, the logical condition in which the strings are used. So I want to verify that all the strings related to macro are enabled, are contained on that file, and at least 1 string that identifies automatic execution. So I decided to show this rule because it is going to be demonstrated later on an attack that I have. Now the other component, Zeek framework. Zeek is very, very powerful, and it used to be known as BRO, and they recently changed its name. So it can basically analyze the network traffic and create, by default, a lot of logs that are going to provide a lot of visibility to the environment. So it turns out that it can natively extract files from the clear text protocols that it observes. But you have to enable that functionality on Zeek. So YARA has been traditionally used mainly on the endpoint to detect malicious files. But I noticed that whenever I wanted to detect malicious files on the network, I couldn't find a readily available tool to do this. So I found that these two tools can be integrated very easily to enable that functionality. And they are open source tools. So you have your typical enterprise network diagram, and you have to decide where to place a span port that could be on your core switch. Then you send that span port to your Zeek sensor, and by default you will have your event-driven IDS logs created by Zeek. But if you enable that functionality for file extraction, you will also have a lot of files to analyze. Then you can enable that YARA scanning on the extracted files, and you can send an alert to the security team that you have so that they can take action on any detection that you have with your YARA rules. And by having the event-driven IDS logs, you can enrich that alert to better help the analyst decide if it's a false positive or a true positive and take action on that event. So to enable the file extraction on Zeek, it is very easy. You simply have to go to the configuration file and enable a default file that it already has. And it is basically the extract all files directive. You have to add that to your main configuration file and then deploy the configuration again. And that's it. It's going to extract all the files. But it also extracts files from SSL communications, so you don't actually have the content. You only have details about the SSL communication. So another approach would be to not extract every file. So only target very specific mime types that are used commonly for malware delivery. So this will have the benefit that files will be retained for longer. You will have increased performance. But it is a trade-off because if the attacker is using a mime type that you're not extracting, he could evade detection. So here are the files that you could extract, which are commonly used on malware delivery. So I decided to extract compressed files, Microsoft Word documents, PDF files, RTF files, and text files that could also allow you to detect some PowerShell, JavaScript, BBS-based attacks. If you're interested on how to do this, I also wrote a white paper that will be available on the Black Hat Media server, and that will have the exact configuration file that I use to extract very specific mime types. And as you can see, it is very clear to understand how it works, and you can easily extend it to add or remove any mime types. So we will have our spam port. We will send that to our Zeek sensor, and now that we have configured the file extraction functionality, we will send those files to a specific folder of extracted files. Then we will have a cron job that will run my custom Python script every minute, and that custom script will take all the YARA rules that are defined on a specific folder and will scan all the extracted files from Zeek with those rules. And if there is any match, it will go to the Zeek logs and get additional context, such as the IP addresses that were involved, the URL, the domain name, user agent, and other fields, and will copy those alerted files to another folder so that they can be retained for a longer period. Then it will send the analyst an email alert that will contain all the context. And after that, it will remove all the files contained on the extracted files folder so that on the next minute, the scan will be much faster because we will only have to scan the files that were extracted on that minute. And then it repeats. In my experience, I have been successful at running this script every minute, but obviously that can change based on how large your network is, how many files it sees, so it can be configurable based on your environment. So what YARA rules to enable on your environment? I think that every organization should have a security team able to write their own YARA rules to identify any campaigns that they spot on the wild, to identify malware families, but also you have to use the resources from the community. So luckily, YARA rules are available, and there are many groups that provide very good quality YARA rules, such as CSIRT teams, CERT teams all around the world. We also have the very talented Florian Roth, who provides a lot of very good YARA rules to the community. And we also have the YARA Rules project that provides YARA rules for free. And also public threat research that is provided by various security vendors on their information about the threats that they do. They normally include indicators of compromise, but also they include a section with YARA rules that detect the artifacts of the campaigns that they analyze. You also have some close threat research groups like the YARA Exchange community. So to demonstrate this capability, I decided to focus on a very prevalent threat attack vector that is basically the Microsoft Word documents with malicious code. And as you can see, this threat attack vector has been used for years, and at least 2014. And the latest example that I found was of the last month, right? So, and I think it's still going to be used a lot. So that is why I decided to create a YARA rule to detect this kind of files. So basically, this threat attack vector is normally used on phishing emails. And as you can see on the screen here, I'm using a proof of concept server that I used to test this kind of functionality, this kind of detection capability. So it includes whatever lure to make the user click on the link and download an invoice. So now I'm going to play this demo for you to see how it works. So the user clicks on the link, the file is downloaded, the user opens the file, and while the user is reading this document, he sees that he has to enable the macro code, and he proceeds, he enables the macro, and the code runs on his machine, but by this time, Zeek already extracted the file, and I already scanned it with YARA and sent the security analyst an alert, an email alert, which includes all the information required to act and do something about it. So it is only a detection control. The code is already running on the victim, but it has not passed a lot of time before that. So as you can see, the analyst now has the information, and he can act and do something about it. So now I'm going to show you what details are contained on that email. So the very first part is the YARA rules that were alerted. So here in this example, I have two of my rules that I wrote triggered on this file. But in addition to that, I also have a rule of a trusted third party, in this case Florian Roth, that had a rule that also detected this file. So basically, if we have more detections or more YARA rules, it is higher confidence. Then we include details about the network communication. If the file is very large and it cannot be added as an attachment to that email, we place it, we add basically the path where it will be stored on the Zeek sensor. So the analyst can go to that path and retrieve the file for additional analysis. Then we also have the IP address of the command and control server or the delivery server that was used in this attack, and also the IP address of the client that clicked on the link, and also the HTTP details such as URI, domain name, and method, in addition to other fields such as user agent. We also include, if the file is smaller than the threshold defined on the script, we include it as an attachment, and it is protected with a password. So basically, we can move it to an isolated environment to analyze it further. And with this, I conclude my demonstration, and I want to end by talking about the challenges and the next steps of this project. Well, the greatest challenge is the fine-tuning, because it can be initially hard to decide what YARA rules to enable from third parties, especially because you sometimes are not sure of the quality that they have. So you have to test that and really make an effort on deciding what third-party rules to enable, in addition to your own rules. Then it will also require some tuning to decide what meme times to enable, depending on how much traffic you see on your environment, how big it is, and if you decide to make it a very targeted extraction or maybe extract more files. Now, let's talk about the next steps. On the next versions of this project, I'm going to automatically create an event on the MISP platform, which is basically another open source project created by the Luxembourg CERT team that is used on all the first community. So basically, a lot of computer emergency response teams around the world use this tool, and with this, I'm not only going to send an email alert, but also automatically create that event on our threat intelligence platform so that we can share indicators rapidly with other security teams. And also, I'm going to send the alert to Elasticsearch and syslog, and have some support for exclusions. Also, exclude by domain, URL, IP address, etc. And see if there is any support to integrate it with solutions that can open SSL traffic. So right now, I don't know if that will be possible, but for sure, I'm going to test that. Then I will migrate the Python script that I developed from version 2 to version 3 and evaluate any integration with Sandbox and SOAR solutions. Feel free to download my script from that resource. And there's a white paper, as I mentioned previously, and it has more details on how to enable file extraction and the components of this solution. So the key takeaways. YARA detection can be implemented not only on the endpoint, but on the network as well. Network-based YARA detection can be implemented with Zeek, which is an open source and free platform. And network-based YARA detection is generally faster, in my experience, than scanning all the file system of a specific endpoint, which normally stresses the endpoint and causes performance issues. In my experience, scanning all the extracted files on 1 minute is very, very fast. Obviously, it could take longer on a larger environment. So finally, I want to end this presentation thanking to the open source projects that I used and that are really great, the Zeek project, the YARA project, and also to the threat researchers that share information with the community. So Victor Manuel Alvarez, Mila Parkour, and the YARA Exchange Deep End Research Community, Florian Roth, Didier Stevens, Bradford Malware and Traffic Analysis.net, Sans ISC, CERT teams, security vendors that decide to share YARA rules on the threat research papers that they do and release to the public. And with that, I want to thank you for coming here and listening to me. Do you have any questions? Thank you very much.